The goal of the grant is to determine some parameters for production, like what's the yield between the caterpillar spaces and the high tunnel spaces. What's the nutritional quality of the greens that we've cut and then stored in the cooler and then sent the lab samples into the samples into a lab. Like what's the nutritional composition of greens that we just harvested fresh, and then what's the nutritional content of the greens that we've harvested, stored for a month, and then sent those samples into the lab. So we plant them in late August, early September. Get them irrigated, get them germinated, and then ultimately get them really exposed to the first round of really hard frosts. And then at that point, they develop more of a hardiness, and we're able to finally put the caterpillars on top of them. We might even sneak row cover on them to get them even more exposed to colder temperatures before we put on those warm suits. And then once we've got them good and acclimated to the real shit that's gonna come in like December or something like that, then in November we'll put the ground stakes out, the hoops, the plastic on top, and they're ready to go. And what we observed was through the process of the grant was really that there are only several types of greens that will really thrive with that kind of management. In the process of trialing different greens in those spaces with that strategy of planting them, exposing them, and then covering them up eventually, the mustards really didn't pan out all that well. Like the spicy greens species that we were growing, the yield just after we brought them into cover wasn't very high compared to things like spinach and baby kale and that sort of thing, chard. Basically at this point it's just spinach.
Unlike a greenhouse that you plant and then you have no control, like if it's basically no control, like if it's really warm in the fall, that space is going to heat up, you're going to see growth going through the roof.
Right.
Whereas with these temporary structures, I think what we've realized in just thinking about, for the grant, and comparing the structures and their benefits and their drawbacks, is that this we can put up anytime.
Right.
And either speed up the growth or hold back and just let them basically operate at 50 degrees, which they grow really slow in that temperature range.
Right.
And also they're way hardier than the ones in the high tunnels that have been sort of babied more or less. Because what we've been noticing also is once you've conditioned these greens in the cold temperatures, they're almost like prime for refrigeration and storage. But we have a question about whether the nutritional content degrades over that time, whether it's like, robbing Peter to pay Paul or something, I don't know.
And so what are those results have you found?
One of the key findings that we had was that different structures require slightly different seeding dates for maximum production and also minimal crop loss. Seeding in the field, for example, and being able to build a temporary caterpillar tunnel allowed for earlier seedings, like 2 to 3 weeks earlier. And we did that because the heat units don't create the conditions for quick growth in October and November. Tunnel seedings need to be delayed so that leaves don't get too big and so that they're not susceptible to hard frosts. Second key finding was some plant species like the mustards, brassicas, and many of the lettuces we trialed, they're just too frail for reliable winter production in our climate, regardless of whether they're grown in high tunnels or the caterpillar tunnels. It's not that they don't produce food, it's that the time it takes to harvest makes growing and protecting these greens unprofitable compared to other greens like green spinach, red spinach, chard, kale, and claytonia. A winter production farm only has so much time to harvest during thawed windows of time, when solar energy heats up the greenhouses and allows you to get out there and start harvesting. So there's a time scarcity, and this scarcity informed us kind of a study design change between the winters of 2019 to 2020 and between 2021 and 2022. Our data collection scope of the study really shrunk so that we could answer questions related to different spinach species or varieties seeded at different time periods in these two different structures. The third key finding was that mustards grown in high tunnels and caterpillar tunnels were far less productive than spinach, unless these mustards were harvested before single-digit outdoor temperatures, typically before December. Another finding that we had was that spinach yielded best between 15 hundredths and 0.158 pounds per foot when the following criterion was met. When that spinach was seeded at the optimal periods for their given structure, whether it was high tunnels or caterpillar tunnels, whether that spinach was exposed to frigid temperatures when outdoor temps dropped into the teens and single digits under one layer of row cover, when that spinach was covered with additional row covers as outdoor temperatures moved into the negative degrees, and almost most importantly, when minimal / no eating damage occurred from moles, mice, shrews, and pocket gophers. That was ultimately one of the key drivers for yield. Another key finding was that the yield of spinach seeded too early and was minimally protected appeared just as unproductive as highly protected spinach that is eaten by rodents. So those are two huge pitfalls in the winter productions of greens, whether or not you grow them successfully and have good successional slots of time when they're being grown. So our analysis of the quality of spinach after storage was that no spinach from samples harvested on January 26th and stored through March 2nd was discarded after this long-term storage. So there was over a month's time that spinach was able to be held in our refrigerators, stored between 32 and 36 or 37 degrees. And all of those leaves were deemed high quality visually after this storage period. There were no signs, for example, of yellowing or dehydration. We found that for future samples, we recommend using NP analytical for nutritional testing. We heard from researchers at Montana State University that this particular lab is willing to measure time-sensitive samples the morning after they've shipped overnight to them, which is quite different than the lab that we sent into. Vitamin C and folate dropped significantly, which our consultant said was to be expected. She said just 15 days can drop vitamin C, so the 6-day delay that we experienced just in shipping and having them arrive might have already dropped the vitamin C. Okay, vitamin C seemed to increase slightly, which may be due to moisture loss or post-harvest biochemical synthesis. So the plants might have been responding to organisms that they were trying to fight off, is what I heard as a rationale for why vitamin A might have increased. But it also may have been just only one replication of the study, so of the leaves. So it might have been a mis analysis, I guess. Vitamin K did not seem to drop significantly, and unlike the other nutrients, the results of vitamin K did not draw a comment from our consultant.